Hey class, since I'm not there today, I have a video for you. So go ahead and fold this paper in half, and we are going to take notes on standard form of linear equation and also graphing with intercepts. So first thing we need to talk about is standard form. So standard form is written in the way of ax plus by equals c. And you wonder, well, what is a, b, and c? A, b, and c are just constants. So constant numbers. They're just the coefficients of a, b. A and b are just coefficients of x and y. And then other thing, just particular with a, is that it must be positive to be in standard form. Okay, so there are two ways to graph functions. So if you have it in standard form or just not in the y equals mx plus b form, then we've got to do one of two things. So the first way is we are going to rearrange the equation to say y equals mx plus b. That's your slope-intercept form. And we've practiced this a little bit. We're solving for y. So let's do an example where we have the equation 5x plus 2y equals 16. So in order to graph this, method one suggests that we rearrange the equation to say y equals mx plus b. So that's what we're going to do on this one. So that means we need to say y equals. So we need to solve the equation for y. So we're going to subtract 5x on both sides. So those cancel, and I get 2y equals, since it says mx plus b, I want it to be in that same form. So I'm going to move this up front because I can't combine them. So negative 5x plus 16. Okay, and then we're still trying to get y by itself. So that means we need to divide by 2 all the way through. So those cancel, and I get y equals negative 5 over 2 x plus 16 divided by 2 is 8. Okay, so just to make sure we know about slope, remember slope is this, and this is our y-intercept. I abbreviated. So our m is negative 5 over 2, and b is 8. One thing that we could do, which would be just to change this negative 5 over 2 to a decimal. And so our equation would be negative 2.5x plus 8. But it's easier to graph whenever you have a fraction, negative 5 over 2x. Okay, so let's say we wanted to graph it. So we would graph our 8 first, remember? So we'd go, I'm just going to draw some lines. 1, 2, 3, 4, 5, 6, 7, 8. And put a point. So that's on our y-axis. It's our y-intercept. And then 5 over 2. So that means rise negative 5 and run 2. But since we're rising negative 5, that actually means we're going to go down 5 and over 2. So I need to make sure I have some numbers on the x-axis. So I'm going to go down 5. 1, 2, 3, 4, 5. And over 2. 1, 2. So that gives me some points, something like that. It's not going to be perfect. Okay, so that is what the graph could look like. Sorry, my line. Maybe I should have used a straight edge. That might have helped a little bit. Okay, so anyway, it's just a sketch. And it's messy. Okay, so that's method 1. That's what we already know. So method 2 is using that standard form. So I'm going to put use standard form to find the x and y intercepts. So for those of you who have forgotten about intercepts, let's go back in our journal to that purple foldable that had slope dude on it. Oh, sorry, guys. Okay, so here are intercepts. So the x-intercept is where the line crosses the x-axis. X-intercept is a number, y is a 0. Y-intercept is point where the line crosses the y-axis. X is 0, y is a number. So in order to find the x-intercept, we are going to plug in 0 for y and solve for x. So let's go ahead and do that. So I have this example over here, so I'm going to use that. 5x plus 2y equals 16. So it says plug in 0 for y. So I'm going to do 5x plus 2 times 0 equals 16. Well, 2 times 0 is 0. So all I'm left with is 5x equals 16. So in order to get x, I need to divide by 5. So x equals 16 divided by 5, or if we divide it, it's 3.2. Okay, and then find the y-intercept. We are going to do the opposite. Plug in 0 for x and solve for y. Y-intercept, you're going to solve for y. X-intercept, solve for x. So on here, we are going to do 5x, nope, not x, 0, plus 2y equals 16. 5 times 0, 0, so I just get 2y equals 16, because that canceled out. Divided by 2, y equals 8. So that means the y-intercept is 8. It says graph your intercepts and connect the dots. So I need to graph the x-intercept. So I want a coordinate, so x, y. So I'm going to have 2 coordinates. One of them is my x-intercept, and the other one is my y-intercept. So for my x-intercept, remember 0 is for y, 3.2 is for x. So x, y, so 3.2, comma 0. And then my y-intercept is at 8. X was 0, so it's going to be 0, 8. So if I look at this, it was supposed to be 3.2, which is right here. And then 8, which is right here. Just looks like my drawing's off a little bit. But it's on the same line. And we can actually check this with the calculator too. So get your calculator. If you don't have it, go get it. I'm going to put the equation in. So I put negative 2.5x. But I could have done negative 5 over 2. X plus 8 to get my equation. I want to see what it looks like, so I need to go to graph. And here it comes. Looks pretty similar, just my sketch is kind of funky. So what we can actually do is we can hit trace and we can follow it along and look, there's 0, 8. It's that point right there. And then let's arrow over. And look, 3.181818, and that's it. So what would that round to? Well, 3.2. And then 0.0454. That's really close to 0. So it looks like it's on that line, on the x-axis. So we did it right. So these were the two methods. Okay, so let's look at actually graphing it with a good graph, since I just had to sketch it on that last one. All right, so here's our example. 3x plus 5y equals 15. So we are going to do method 1 first, and then we'll do method 2. So method 1, convert to standard form, to slope-intercept form and graph. So slope-intercept form is mx plus b. That's our most popular equation in algebra. So 3x plus 5y equals 15. So I need to subtract 3x on both sides because I'm getting y by itself. I'm left with 5y equals, I want to put in mx plus b, so negative 3x plus 15. And then divide by 5 all the way through. So y equals negative 3 over 5x plus 15 over 5 is 3. This could be 3 divided by 5. If you divide that out, it is 0.6x. So these are, of course, the same. I just wanted you to know that slope can also be written as a decimal. It doesn't have to be written as a fraction. Okay, and then what we need to do is we need to graph it by using m and b. So your m is, I'm going to use the fraction because that's easier to graph, rise over run. And then our b, our y-intercept, is 3. So you always graph this first. So on the y-axis, so that's your y-axis, you're going to graph at 3. Okay, and then the next thing you're going to do is your slope, which is negative 3 rise. So that actually means go down 3, and we're always going to run right. So down 3, 1, 2, 3, and run 5. 1, 2, 3, 4, 5. And we could continue doing the rise over run. So down 3, 1, 2, 3 over right. 1, 2, 3, 4, 5. Then we could go up to the top. Oh, I didn't have that showing. I'm sorry. That just went down 3 and right. Okay, now go up 3. 1, 2, 3 over 1, 2, 3, 4, 5. Then again, up 3. 1, 2, 3 over 1, 2, 3, 4, 5. Okay, so then we'll use a straight edge. So ruler. I'm using Post-it notes because I don't know what I'm doing. Okay. And then put arrows on the end because it extends on and on forever. Okay, so that is method 1. Okay, let's do method 2. So method 2 says graph your intercepts. So we are going to do x-intercept. So let's look back at what it says to do for x-intercept. It says plug in 0 for y and solve for x. X-intercept, we're solving for x. So we're solving for x, so we're going to plug in a 0 for y. Okay, so 5 times 0 is 0, so we're just left with 3x equals 15. So divide by 3. 15 divided by 3 is 5. That's your x-intercept. Okay, then your y-intercept. We're going to solve for y, so we need to plug in 0 for x. So I'm going to plug in 0 here. Whenever I do that, 3 times 0 is 0. So I just have 5y equals 15. Divide by 5. Y equals 3. But in order to graph these, I need points. So here, x is 5, and y was 0. Remember, this is x, y, coordinate plane. And then x is, or on the y-intercept, x is 0, y is 3. So then we plot those points. So 5, 0 right here. 0, 3 is right here. If we connect those and extend the line, looks like that. And aren't they the same line? They sure are. So this was the same line, just two different ways. So we've already done it this way. We'll come back to doing that some more, but this lesson today was all about finding your x and y intercepts. So you need to put this in your journal and then update your table of contents, and then I have this as your assignment. So it says graph using intercepts, exit ticket, and then on the back it just has some practice problems. On number 2, these answer choices are not right. So you can skip this altogether, or you can do it as a bonus to find the point or the line that passes through those 2 points. But you've got to show your work. All right, so over here, graph using intercepts. So you're going to use your notes. So this says identify x and y intercept on the graph. So we're going to plot these as points. So our x-intercept is right here, which the point for that is at -3, 0, because we have x, y. And then our y-intercept is at 0, because we're not going left or right, -3. Okay, part 2 says find the intercept and y-intercept of the graph. So that is doing just what we did on method 2, which was finding the x and y intercept. Okay, and then these last 2 problems. Graph the equation using intercepts. Label the points where the line crosses the axis. So you are going to have to find intercepts and graph those. Make sure you show your work on all of this. Okay. All right. Have a good rest of your day, and I will see y'all tomorrow.